Hello everyone, welcome to my channel. In this video, I'll be teaching you about the six trigonometric ratios: the sine, cosine, tangent, cosecant, secant, and cotangent. So here are the objectives of our lesson. At the end of the lesson, you will be able to compare and contrast the six trigonometric ratios and predict the values of the six trigonometric ratios and be grateful for the support of God and the people around you and perform activities related to the ratios of the lengths of the sides of a reference triangle. So there is trigonometry in everything that we do in life. Whenever there is an object to be observed, the line of sight from the observer to the object observed forms an acute angle. This acute angle is inclusive in a triangle, and thereby the basic concept of trigonometry evolves. So here are the six trigonometric ratios. Again, when we say trigonometric ratios, it is same with the trigonometric functions. The sine, the cosine, tangent, cosecant, secant, and cotangent. So here in the six trigonometric ratios, the sine is the reciprocal of cosecant. Cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. Okay, so trigonometric functions are ratios. The sine ratio, the cosine ratio, and the tangent ratio are the three ratios that compare a pair of lengths of sides of a triangle. These ratios remain the same regardless of the size of the triangle for as long as it is right triangle and the other angle measures are kept the same. So next, we have to label the sides in a right triangle. For the trigonometric functions, the following labeling convention must be applied at all times with reference to a given angle. So in this triangle, this symbol is called theta, or theta represents an angle, represents the measure of the angle. And the side beside theta is called the adjacent side. And the side that is opposite to theta or to the given angle is called the opposite side of a triangle. And then the longest side always of a right triangle is called the hypotenuse. Or when say hypotenuse, it is the side that is opposite to a right angle. All right. So the hypotenuse, or in symbol, it is letter H, is opposite the right angle, 90 degrees. The opposite side, or O, is opposite the given angle, theta. The adjacent side, or A, is next the given angle, theta. So trigonometric functions are used only in right triangles. It is used to find an unknown length given an angle and the side, and to find an unknown angle given two lengths. So here are the formulas of the six trigonometric ratios. By the way, the sine, the cosine, and the tangent functions can be seen in a scientific calculator. So we have to use the mnemonics SOCAT TOA to help us remember which combinations of sides are in each of the three ratios. Label sides of the triangle with respect to the given angle. This is so. It is the formula of sine. It means that it is the sine ratio when using opposite side in the hypotenuse. And ka is the cosine ratio when using adjacent side in the hypotenuse. And TOA is the tangent ratio when using opposite side in the adjacent side. All right. So here are the formulas of the six trigonometric ratios: the sine, cosine, tangent, cosecant, secant, and cotangent. For the sine, the formula is so, or sine theta. Again, theta represents any measure of the angle. Like for example, sine 35 degrees equals opposite divided by hypotenuse. Or let's say sine theta equals opposite over hypotenuse. And for the next one, the formula of cosine is ka, or cosine theta equals adjacent divided by hypotenuse. And for the formula of tangent, it is TOA. Tangent theta equals opposite divided by adjacent. And cosecant is CHO, or cosecant theta equals hypotenuse divided by opposite. And for the secant, it is Shra, or secant theta equals hypotenuse divided by adjacent. And for the cotangent, the formula is cow, or cot theta equals adjacent divided by opposite. So again, always remember that sine is the reciprocal of cosecant, and secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So to memorize quickly the formula of the six trigonometric ratios, we will use it in a sum. For example, Sokatoa chusrakau, Sokatoa chusrakau. Again, Sokatoa chusrakau, Sokatoa chusrakau. All right, so let's say so, it is for sine. Sine theta equals opposite divided by hypotenuse. When I say ka again, it is for cosine. Cosine theta equals adjacent divided by hypotenuse. And let's say TOA, it is for tangent, or tangent theta equals opposite divided by adjacent. And let's say CHO, it is cosecant, or cosecant theta equals hypotenuse divided by opposite. And when we say SHA, it is secant theta equals hypotenuse divided by adjacent. And when we say cow, it is cotangent theta equals adjacent divided by opposite. So we should apply the six trigonometric ratios in example number 1. Like for example, the terminal side of angle A contains the point 3 and 4. Find the trigonometric ratios of A. Here, before we solve for the six trigonometric ratios, so we have to complete first the lengths of the three sides of a right triangle. So here, there is a missing length, which is the hypotenuse. So we need to find the measure of the hypotenuse first. So again, to find the missing length of a right triangle, we have to recall the Pythagorean theorem. Our R here is the hypotenuse, so we have to apply the Pythagorean theorem to find the length of the hypotenuse before we solve for the six trigonometric ratios. All right, so what is the formula of the Pythagorean theorem? Okay, so here. So to solve for the hypotenuse, or R, using the Pythagorean theorem, the formula is R squared equals x squared plus y squared. Okay, we have to substitute x by 4 and y by 3 to find the measure of the hypotenuse, or R. Our x is 4 and our y is 3. We have to copy squared. Okay, R squared equals 4 squared plus 3 squared. 4 squared means 4 times 4, it is 16. And 3 squared is 3 times 3 is 9. Okay, R squared equals 16 plus 9 is equal to 25. So to solve for R, because there is squared beside, okay, we have to apply the square root property. Okay, to extract squared, okay, we have to cancel square root and squared. Okay, therefore, R equals square root of 25. What is the square root of 25? Okay, the answer is 5. Therefore, the measure of the hypotenuse here is 5. Okay, we have to write 5 here. So next, we have to find the trigonometric ratios of the given triangle with the lengths 4, 3, and 5 for the hypotenuse. Okay, first is for sine. So what is sine A in the given right triangle? Okay, so because our given theta here is in this angle, okay, so the side that is opposite to this angle is y. Okay, therefore the opposite side is y. And then the side next to this angle A is x, or 4. Therefore, x here is the adjacent side. And then again, always remember that the line opposite to a right angle is called the hypotenuse. Our hypotenuse here measures 5 units. Okay. So to find the measure of sine A, we have to use the formula SO, or sine theta, or sine A equals opposite divided by hypotenuse. Okay? So sine A equals so. That is the formula. Okay, S stands for sine, O is opposite, and H is hypotenuse. Our opposite is 3, and our hypotenuse is 5. Therefore, sine A of the given triangle is 3 over 5. Okay, next, let's proceed to cosine. Okay, the formula of cosine is K, or cosine theta equals adjacent divided by hypotenuse. The adjacent side of angle A here is 4, and the hypotenuse is 5. Therefore, the measure of cosine A is 4 over 5. So next, let's proceed to tangent. Okay, the formula of tangent is TOA. When I say TOA, it is tan theta equals opposite divided by adjacent. Our opposite side is 3, and our adjacent side is 4. Therefore, tangent equals 3 over 4. So now let's proceed to cosecant. For cosecant, the formula is CHO, or when I say CHO, it is cosecant equals hypotenuse divided by opposite. Our hypotenuse again is 5, and our opposite side is 3. Therefore, cosecant A is 5 over 3. Now, let's proceed to secant. Secant A, or the formula is CHA, or secant equals hypotenuse divided by adjacent. Okay, our hypotenuse is 5 and our adjacent is 4. So 5 over 4. For cotangent A, the formula is cow, or cotangent equals adjacent divided by opposite. Okay, our adjacent side is 4 and our opposite is 3. Therefore, cotangent A is 4 over 3. Okay, so as you have noticed, sine is the reciprocal of cosecant, because in sine it is 3 over 5, but in cosecant it is 5 over 3. So it is just reciprocal. And in cosecant, 4 over 5 is the reciprocal of 5 over 4. Therefore, cosecant is the reciprocal of secant. And tangent is the reciprocal of cotangent, because in tangent, the answer is 3 over 4, and in cotangent, the answer is 4 over 3. So in example number 2, solve for the unknown length of the right triangle and find the values of the 6 trigonometric ratios of angle B. So here, we have the missing length of a triangle, which is letter B. So here in our figure, the given angle is angle B. So we have to focus only in angle B to identify the sides of a right triangle, whether it is hypotenuse, it is opposite, or it is adjacent. Again, the side that is opposite to angle B is the opposite side of the triangle. And the side that is next to an angle is the adjacent side, or we have to write a label, letter A, for adjacent. And always remember that the side that is opposite to a right angle is the hypotenuse. Okay, so we have here, our opposite is the side B, and our adjacent side is the side A, and our hypotenuse is the side C. Okay, so we have no measurement for side B, or for the opposite side. So we have to solve this measure using the Pythagorean theorem. Okay, solution. Solve for the opposite side using the Pythagorean theorem. The formula is c squared equals a squared plus b squared. Our a is 4, our c is 6, and our b is unknown. Next, we have to substitute c by 6 and a by 4. So 6 squared is 36, 6 times 6 is 36, and 4 squared is 16, because 4 times 4 is 16. All right, so we have to transpose 16 to the other side. If it is positive, it will become negative. Therefore, it is 36 minus 16 equals b squared. 36 minus 16 is 20. Okay, so we have squared beside b, so we have to apply the square root property. We have to write square root both sides. So we have to cancel squared, we have to cancel square root. Okay. And b is square root of 20. 20 is not a perfect square, but we can find the factors of 20 that the other factor is a perfect square. So what are the factors of 20? It is 4 times 5. Okay. Or we have to change directly square root of 20 into decimal, which is 4.47. Okay, therefore, side B here is 4.47. So after we complete the sides of a right triangle, we have to solve next the 6 trigonometric ratios of angle B. So we have the label already. We have the adjacent side, the opposite side, and the hypotenuse. Our adjacent is 4, our opposite is 4.47, and our hypotenuse is 6. Okay. So we have the sine B, the cosine B, the tangent B, the cosecant B, the secant B, and the cotangent B. Okay. So again, the formula in solving sine is so. The formula for cosine is ka. The formula for tangent is toa. The formula for cosecant is cho. The formula for secant is sha. The formula for cotangent is kau. So, ka, toa, chu, sha, kau. Okay, so let's proceed to sine. The formula again is so, or sine equals opposite divided by hypotenuse. So our opposite side based in our figure is 4.47 divided by the hypotenuse, which is 6. Therefore, the value of sine B is 4.47 over 6. So we cannot simplify 4.47 over 6. Therefore, that is the final answer. And for the cosine, the formula is adjacent divided by hypotenuse. Our adjacent side is 4 and our hypotenuse is 6. All right, so to simplify 4 over 6, we have to divide both numerator and denominator by 2. 4 divided by 2 is 2 and 6 divided by 2 is 3. Therefore, the simplest form of cosine B is 2/3. And for tangent B, we have to use the formula opposite divided by adjacent. Our opposite side is 4.47 and our adjacent side is 4. Therefore, the value of the tangent B is 4.47 over 4. And for cosecant, we have the formula cho, or cosecant equals hypotenuse divided by opposite. Our hypotenuse is 6 and our opposite is 4.47. And for secant B, our formula is sha, or hypotenuse divided by adjacent. Our hypotenuse is 6 and our adjacent is 4, or in simplest form, it is 3 over 2. All right, so for the last one, for the cotangent, the formula is kau, or adjacent divided by opposite. Our adjacent side, again, is 4, and our opposite side is 4.47. So again, always remember that sine is the reciprocal of cosecant, cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent.